We'll be starting the session in 2 minutes. Good evening, all. Today we are having day 2 of session 1 of our 6 days online FTP. The topic for today's session is how analog device is pioneering soft design for data centers and beyond. The session will be handled by Mr. Ratish Tekevitil, holds an MTech in digital signal processing from IIT Guwahati, is an experienced semiconductor professional with over 18 years in design for testability, contributing to successful first silicon bring up for more than 20 complex SOCs. He is currently director at Analog Devices Bangalore, leading DFT architecture and SOC debug for advanced products. His expertise includes SCAN, ATPG, MBITS, LBITS, functional safety in field test, analog, and large-scale SOC debug across ADAS, server, client, IoT, and microcontroller platforms. Riddhi sir also holds multiple patents and has published technical papers in DFT domain, reflecting his strong technical leadership and innovation. Welcome you, sir. Now the session is all yours, sir.
Okay, thank you. Thanks for the nice intro. Okay, so happy evening to all. I hope all are taking the session from college.
No, sir, from home.
So, yeah, good evening. It's indeed a great privilege to connect with you all in this evening. And thanks to Dr. Suresh, your principal, who is my buddy, and also FDP coordinator Amal Thomas for inviting me to this event. And also, I have a great respect for all you educators of today who mold the young minds of tomorrow. So, with that note, let me start the topic of the day today. Let me share. You're able to see the presentation PPT?
Yes, sir.
Okay, okay. Audio and all are clear, right?
Yes, everything is clear. Perfect.
Okay, fine. So then let's get started. So the topic is how Unlock device is pioneering SoC design for data center and beyond. So thanks, Amal. So the topic is title is suggested or prepared by him, and then it's reviewed with me and then taken forward. So I'll try my level best to meet to the subject expectation. So let us see, but I may not be exactly talking to this line. And also another point from the unlock device perspective, there are a lot of um, uh, uh, rights and other things are there. So I'll not be able to share insight of this, but as much as presentation is going to be a more or like generic case. Okay, so let's me talk about unlock device. So the unlock device is a multinational semiconductor company. So it's mainly specializing on the data conversion, signal processing, and power management technology. So, and then a lot more. So this even concentrating or giving a solution to the automotive, healthcare, and multiple aspects of it. And that headquarters in Wilmington, which is in US. So now, today's outline of this presentation. So what I will talk about the journey of ADI, couple of slides. I will talk about how ADI comes from its beginning. And we'll talk on the ADI today. What is ADI today? Then we'll get into SoC, a silicon on chip. What is SoC? you couple of folks you might be knowing the flow and other things, but some of you may not. We'll talk about that and SOC development flow. Then we'll later get into the manufacturing and test flow. So the ADI 60 years ago, 1965 is exactly, it started with the two MIT graduate. Okay, then their first target was to produce the high performance op amp. That is with that intention, or maybe getting into semiconductor industry, semiconductor solution, they started the company. So that time, if I'll get into the snapshot of 1965 or 1960 to 70 time frame, Analog Devices released the three product and 46 of employees were there. The revenue around 574K dollar. From that, in 1970, so there is a lot of performance, a lot of SOCs requirements comes, especially in the NASA programs where multiple flagship starships are there, and then there is a lot of different components going of SOC subsystems, SOC and other things in the demand of different power, different processing, etc. So Analog Device got solution space. So in that 1970 to 70 to 80 or like 70, 75 snapshot, if you look at it's grown to 834 employees. And then there are like 163 products with a $3 million revenue. The next decade, we all know that 1980s, the machines, this era of machines like desktop computer or birth of CD player or AV, audio video system and hard drive and everything. So this was a great opportunity for even Analog Device get into the solution space in the form of SOC. So they have grown to 4,700 plus employees with the 322 million revenue. So now you can see here that it's around 20 technical fellows. So the way fellows are typically, technical fellows are the typically folks who give the technical direction to the company, what need to be produced next, what is the technical direction, which area to be invested. So that time onwards, the Analog Device was growing the technical fellows, and there is a lot of different angle or aspects are looking for who can be, who will be, etc. into technical fellow. From there onwards, it's grown a lot of senior folks into this level. And into 1990s, it's getting to the more digital. You can say that like the World Wide Web and other digital technologies across the world. And then there is a lot of need of physical and digital connection, bridge between physical interface to the digital. And then that you can say that it's a healthcare, home theater, image processing, and many of the items are coming underneath it. So that time, this is one of the known or very prominent thing in from the Analog Device, the solution Sharp processor, which is a ADSP, digital signal processing 21060, which is introduced in 1964. So it's the first for Sharp family. With this, 1995 Snap is grown to 6,000 employees with new. Now getting into 2000s, this is the one of the innovation item what EDA is produced is like touchscreen. Here that was lady 7873. This is the first you say that the charge to the digital signals. So whenever you touch on the screen, the appropriate signals and where all the informations to be processed into the further down the line. This is one of the breakthrough for the next decade of touch. Touch become like a gesture now, and it moves on like that. So company become $1 million to $2 billion, 2.4 million billion revenue. with 8,000 plus employees, and the connectivity, the converter market, mainly the data conversion, right? In that market, 40% of the market share is secured. Now, in 2010 is a sensing revolution. So when we say that any of the unit, let's take it as a car in this figure here. You can see that any of the area you need to just capture the information. Let it be your lot of cameras will be there, all other different events of the car will be there whenever the car is moving. All those information has to be captured. It's a sense it's other way around if you tell. So then that things intelligently bridge the digital, and basically the physical world is getting built into the digital things, and sense, measure, and connect. Process that information. Either that process that information upfront and then use it there, or take that into somewhere else and then process it. Maybe multiple cars and going forward, or it will get connected on the road. Say that, okay, this car is going, that car is going. So there will be a lot of information between the things to be get processed and then interchange between this. You can just imagine that two cars are going or multiple vehicles are going. It is getting connected. How the world going to be? It will be interesting. So the sensing revolutions are ongoing, basically. So if the analog front into 9K, and you can see that 100K customers also, with a lot of patents comes into the plate on the different fronts of fans, like 2,200 patents are listed over here. There's a number. Now, 2020 is we call, or analog devices is aiming for an intelligent edge. So this is what for 2030 we wanted to rule the world with that intelligent edge. It's something like, again, physical interact with the digital conversion. So you can just imagine the intelligent edge in such a way that, let us say, if you have a robotic arms or a lot of industrial application, so industry, the multiple informations are getting processed, or the robot has to handle many things. So information to be taken over there, how each of the units are there, each of the units are moving from one flow, manufacturing flow, to another wing, how the precision is there, that measurement, etc. Maybe other way around, you can say that hospital thing, healthcare industry, many of our patients' informations are sensed at the patient level. Just imagine that getting processed. Many of the things has to get processed over there. Then some of the information has to feed back into the doctor's level and to take a decision, and then assume the doctors can give that information back to the patient and understand, okay, how the condition of the patient is, etc. And then many things are like, also, if you another way, cricket or profile, how fast the ball is going, and many things is currently is happening. So that will get growing a lot into the different aspects, and then all your home will be completely digital, and multiple things are there. So end of the day, what it does is that all your physical informations are get sensed over the world. That information will get processed either at the edge itself, whatever the things are required, and some of the information will get passed into the cloud and to get the thing, or some of the information will be processed over there and then get it utilized, and then further will. So this is kind of the area that's the things are happening over there. So it's needed a lot of different processing, different data processing, and then it's again getting into the AML in things to process the data, learn the data, and then take a decision, quick decision, without intervening any human aspects into it. So that's the target which we kept. So if you really look at the AI-enabled intelligent edge, so there will be a lot of unit will be coming, a lot of SOC will be coming, a lot of automation will be coming that process the information and get it utilized and then give the real-time solution there itself. So that's the direction things are moving. So now, as a company perspective, if you look at 2020, there are a lot of recognitions comes to the company saying that it's 100 best corporate place to work, and then another top place to work here in the different forum, and world most sustainable company, etc. If you can just see that it's a 60 years of existence with a lot of analog related solutions are providing for the mankind. So now that's all the journey. So now we reached all like 2025. So at this 2025, So the what we, as I mentioned earlier, also that's we are just wanted to create a more connected the car, more connected the house, more connected, so that's the way it is. It should be safer, and then say it is a sustainable future. So the customer focus point of, if you look at, we have around 75K products now with greater than 100K customers. Industry around 60 years of in industry, and then key technologies like analog and mixed signal. There will be a lot of ADA is a very lead in the analog specific designs. So you have a digital design, you have analog design. A lot of analog designs are happening here inside, like being it a PLL, voltage regulator, such a great precision, etc. Then we'll have a power management as the topic also suggests, like the data center. If you just imagine the data center, so a lot of racks of things are there. So it's need a power again whenever the things are growing. So power is going from a small SOC like microwatt to the megawatt kind of range. So it need a appropriate voltage solutions, etc. That is one of the technology the ADI is concentrating on. Then there is a radio frequency and microwave, your communication, those area, and then the edge processing we already talked about, and then AI and machine learning. So now in the development of the SOC itself, we are getting into the AI and machine learning solutions get utilized in multiple form, like to getting into the coding versus to the verification to the next level of physical design and DFT, any of the many things are getting automated. Earlier days, people used to code manually. So now the coding itself, many things are coming through the ML solution itself. Okay, overall, the investment perspective, $1.5 billion R&D investment, which is very good. And then there are 8K patents now with the ADI. And then now totally we have more than 24K, maybe 25K employees, and spread across 31 countries. So now this is what I was talking, physical to digital aspect. Physical, you sense the data, capture the data in any environment, being it from the car, being it from the industry, being it from the aeroplane, being it from anywhere, and process it. And then measure, basically. You have to just measure, analyze that data, and then make accurate decisions, take into the compute. This all the area, I think your department is maybe machine learning and all those kind of things. So we'll have we have all the SOC VR things are coming with this ML related engine. Most of the deep learning engines and other things are the SOC point of view. Then do the compute and then transfer the data and reliably connect with the other systems, and then take all. I mean, power is another very important component. There will be a power solutions to be there. So overall, what we are doing is like connect the physical world into the digital, also then utilize, make the human life like very smooth and going forward. So, and now look at the industry share currently ADA is having, or so going in this kind of trend. Like industrial area, we supply around 46% of our SOC is going over there, and then there is a 30% into the automotive. That's again the communication as well as the consumer, like audio video systems, your hearing aid and blah blah stuffs, and then like that. This is a 2024 annual revenue thing. And then intelligent edge, as I mentioned, this goes into the renewable energy where the solar systems are there, and then multiple all those aspects, and then sustainable automotive, industrial automation. Then again, the advanced digital healthcare, glucose monitor, those kind of things. And then consumer experience, we have like a hearing aid. One of the key items which I am currently involved to get developed is the hearing aid solution, where let's say if you have a class, so a couple of students, if they're having a hearing aid, or maybe elder people having this thing, so the very good solution. So somebody else talk, so it can be, you have to properly detect the voice. It cannot be like somebody else's voice, right? There are a lot of processing, and then as and when the patient goes into the sleeping during the night time, you will just go and switch off the most of the processing. So the thing is that whenever the hearing aid kind of units are implanted inside the ear and all, so you need a multiple angle of processing, like the system has to know whether the person is sleeping or not. and then according to it will give a more power, less power, data processing, all like kind of now the learning process it's happening. So this is the kind of area which we are tackling. So now the topic, I just wanted to put the ADA solution even going into the data center and AI infrastructure. As I mentioned, you can see the racks of things like cloud computing systems are over here. And then this all need a lot of power. So earlier, like traditional was like 12 voltage and 48 voltage. Now it's become the 800 VDC systems to get the power moving there. So here the advanced power architecture. So ADI provides innovative analog solution critical for power and connectivity in a AI, cloud, and data center. So the thing is that, whenever the cloud systems is switching on and switching off, typically that time there will be a inrush current going. When there is an inrush current, it will damage the unit. So there is a solution to handle that, and all those solution has to be provided. Then connectivity, this data is there, and then whenever the data is getting produced, the data is moved from one side to another side. There is a huge and very good connectivity solutions are required. So from ADI contribution towards this data center and AI, giving the producing and giving the solution into this all spaces. Now, this is what currently I talked about ADI history from where it is started. It started around 1965, and then all the way moved from that to 2025. It's $1 billion federal company, a lot of patents, a lot of innovation getting into the data center. Now we are exploiting a lot of AI related features, etc. Now, what all these? These all are SOC what we produce. Right. These SOCs are going, this is silicon on chip. SOCs are going and sitting in many places and then get utilized to things. Now let us see that what is that SOC. Many of you know, but now I'm just putting a point of discussion. So next session, I think next half we'll be able to discuss, share the information between us. So now just to set the ground, this SOC silicon on chip, you can see that this is an SOC where inside SOC, what all things will be there. There will be an application processor, all this information to be processed. Multiple application processor would be there. There is something main for, there will be something for audio processing. There will be something for video. There may be image processing. All those things need a little bit cache buses and different DDR controller to get the information exchange to the memories, etc. You will be having ADC, DAC, all other PCI information. So another peripheral. So all those things are getting composed in and the form of a silicon, which is called an SOC, right? So now let's see, as a generic block diagram, let us see what is that. I'll just slowly go into the little bit into the technical, but I will not go into the lot deep into the technical. The reason is that I don't know exactly the crowd, what the level multiple domain expert will be there. So it may not be very appropriate to go into deep level. So I'll talk about in little generic. So SOC generic block, if you look at, will be having a CPU. So that is the main kind of unit which will get processed. Attached with there is a memory, there is a L2 memory, L3, all those things will get attached. So as I mentioned, there will be, if it is a image photo processing engine dedicated coprocessor, we call it as a coprocessor or something will be there. Again, video processor also will be there too if it is processed. Otherwise, this guy also can process, but it will offload into the other engines. Now we have a dedicated deep learning engines also to be on top of it. So then we will have a interface unit, like if you have to have a camera unit to get the information taken out and then get processed. The display it has to be displayed into the external world. Then you have an SD card and then USB, etc. to the another memory interface units. So all thing, any of the SOC if you take, right, this is a common thing. It will be like a lot more, and then it will be a lot less, depends on the which application it goes into. So now this is just like there it need a proper system clock, certain power management unit. It will govern how each of the guy to be get the clock's power and all. So all those things are constitute an SOC. When we data center solution, this will be in one form, one different block. When we give this into hearing aid, it will be different unit, different form. But is the generic look is something like that. And then little bit more closer look, one level more. You can see that this Cortex A53 is the ARM IP, which is one of the key processing engine and one of the good IP that it processes the low power kind of a processing unit. And then there is a debug. Once the SOC comes out of it, it goes into the real board, and then there is a software development will be happening. So how do you debug? How do you make the system booting into the Linux? How do we get the system booting into the Windows and all those things? So during that development, we will be using the JTAG. It is a standard IEEE standard, right? So it will get utilized, and then you will be having a different processors like GAC, interrupt controller, and another different coprocessors, etc. And then DMA engine moving the information from one unit to another unit with the help of, without the help of the processor, so that processor can dedicate their bandwidth for the processing. The movement will happen through the DMA engine, etc. So we'll be having this SD eMMC interface to the different file system. You will be having another interface. So another interface which is Ethernet here, it is shown. And then there is a peripheral. Lot of peripheral will be UART, SPI, peripherals will be there. And then again, like kind of a PLL, which is the clocking thing, and the PVT. Many of other things you may be knowing. This PVT is the process voltage and temperature. Let's say if you provide an SOC into some different environment, that environment can be like heated up, maybe mobile. If you are using the mobile phone, after some time it will get heated up. How do you know where the what it is going up? Whenever it's happening, there is a sensing. It will get sensed and then will reduce the frequency and all. Otherwise, it will get damaged. So a lot of PVT, process voltage temperature monitoring mechanisms also there in the system. Also, it is utilized for your manufacturing. Different silicons will come like that whenever you maybe a little bit talk later. And then there will be a timer, watchdog timer, when the system is going for something getting hanged. So it will have its own auto recovery mechanism also. Multiple things are there. All a number of peripherals are having over here in the SOC. Then you will having a QSPI interfaces where all the softwares are stored in the external flashes. So whenever system is booting up, system will start booting up its own hardware for some time, which there will be a processor which will be helped to get the system boot. But after certain stage, it need the software information that will come from the flash. So that flash information will be taken into that, and then it will boot accordingly. So there will be information on the ROM, different information will be hard coded into the ROM, etc. And then you will be having a DDR controller with extended memory, and then there may be some accelerator processor which is sitting outside, which might be doing. So all together, like kind of a constituting an SOC. So now this is what the SOC inside. Now let's little bit get into, okay, now you have this kind of block diagram. Now this SOC has to get converted into the silicon. Okay, so now let me little bit look into the how the partitioning view or silicon view. As I mentioned here, the Cortex MP, like a CPU subsystem will be there inside. N number of cores, maybe we'll group together and call as a subsystem. In SOC development, if you all together look at, we say that subsystem 1, subsystem 2, N number of system, maybe hundreds of subsystem, maybe tens of subsystem, depends on the chip. Hello. I'm not able to hear you, Karthik.
No, sir, everything is fine.
Okay, fine. Thank you. So, so now this is the now physically what we do is, when you take a silicon, in that silicon, each of the unit will go into physically sitting some places. All those unit will be kind of parallelly getting developed physically. Okay, that is called the physical design aspect of it. Now, this is the physical design view. you can see that bottom is a one silicon, and the top level, if you look at, so this assume maybe you can say that this is one area where all this CPU subsystem goes and sit. Maybe next guy, this may be application specific component. Maybe you have a DSP, digital signal processing, or maybe you have a graphics processor, sort of things. Maybe this is not an corresponding one. I just put the diagram to represent how the physically things looks like. And then you may have a modem sitting over here, maybe another peripherals might be sitting here, different. This is the different area all together. And then you can see that SOC interconnect, all cores will get interconnected, or CPU will get interconnected, blah. All these things are sitting spread across. That typically will be spread across the thing, all this bigger unit will be sitting. So the development, whenever we start a development of the SOC, typically SOC development may varies from 1 year to maybe 1.5 years. Sometimes it may take even 2 years also SOC development. All the way maybe 7 months to 2 years can be, you can see. So all those development, we develop all this IP, we develop all the SOC interconnect and connect together. Will be a lot of loss. I'm going to talk that. So eventually the silicon, if you look at in the microscopic view, or I just view the way, the development flow view, this will be the view, basically. So now look at, so what that means SOC, this SOC is everywhere now. Meaning it will be data center, it will be mobile application, aeroplane, car, whatever. Like your communication unit, railway, and then card, anywhere. It is in the small form, big form, or whatever. It's everywhere. So it's good to understand this development flow once, how things are keep moving. So let me get into that level. So this is SOC development flow. This again, that's the same diagram. Let me go over here. So creation of the SOC, how it will come. Amal, the question will be taken the last 30 minutes, right?
Yes, sir. After 1 hour, we can start the Q&A.
Sure. Okay, fine.
Fine.
So now, whenever SOC comes, now we have an idea. The idea is something like this way. You can look at, whenever you are driving the car, so if any passengers are in front of you, the car has to get auto brake. Maybe just take that as one of the idea. So now this idea has to get it converted into a product requirement. So somebody wanted that is what someone want. Maybe another idea is that you are far away, and you wanted to, maybe your let us say that your washing machine or your dishwasher or anything, it's like you wanted to get it operated with understanding that whether the unit is failed, closed, all those things. That may be another requirement, or another item. Or maybe in your refrigerator, maybe let us say that apple is not there or milk is not there. It has to just go and get order. It's automatically. Maybe these all are the different ideas is coming now, or it may be already implemented a lot, right? So when that comes, that it will convert into product requirement. So we'll get into the next level of the things. Okay, how the product need to be. So from the idea, it will get converted into the product requirement perspective. How much, what need to be added? What is this processing power is required? What all the items are required? There will be a lot of discussion on the product requirement perspective. Okay, if this product to be looked at this way, that way things will come up. And then that get into the product specification. You can see this block. So I was showing the different block in SOC. This block diagram will get built, saying that okay, this is what we wanted to build. We'll use a different processing engine, processing engine, memory requirement. Each of the IP will have different specific parameters, etc. So once that product specification is done, then it will go into the development and production. Okay, so it has to get developed into the design and into the silicon. Then after that, it will get produce that silicon into, then it will eventually go into the final product. That's what it's a bigger flow basically. If you get some idea to the product, it may take some 5-6 years also even. So now design steps. Okay, now what I'm going to talk here, once the sort of from here onwards is the product specification to the development. or into the protection, what all the steps are involved. So now idea anyway come from the customers, and then there will be like a different discussion will happen, that product requirement will get tuned. Then once it is clear that requirement, it will get over here. So from here onwards, I'm just talking now. So what are all the steps involved? Design steps for an SOC. First thing, I don't know whether the font is much visible, but let me talk. So market requirement study. So this is what I was talking. Then after that, feasibility. If you have this requirement, now we need to see that feasibility study, whether it can be implemented or not, or in the same scale, or it need to be in different form. So that feasibility study has to be understand and then do. Then we have to do a cost estimate. Some of the solution, let us say that if you are ordering ordering some empty items in your refrigerator to the online market, if that solution is taking the, let's say, a huge amount, that is not a financially viable thing, right? So then you can do, you can go and open the refrigerator and see and then just order it. So there will be a number of cost estimates that are there whether the product is viable or not. And then the die size estimate. This is specific coming to the SOC world. So we do the manufacturing in a different technology node, 5 nanometer. Currently, it is like a 5 nanometer, 2 nanometer, 3 nanometers are going. So that each of the SOC die, how much of that cost involved, how much it will be. Then that similar technology, understand which technology this need to be produced. Let's say what of the technology node, and multiple things will be happening over here. Once this is there, market requirement study is the typical way is that in the company will conduct one the review. That review process will say that okay, this much of market are looking for this product. If we launch this product in the first year, second year, third year, up to 10 year, what will be the revenue coming on? In that revenue, how much of the R&D expenses and other things which we need to do? So then is it a profitable or not? Or a lot of things are there. It will keep studying. Then it will get into a system. Once it is done, approved. Okay, now market is good. Market study is good. Now costing is good. It is feasibility is good, and it can be produced. Now we will get into the system level model. Okay, so system level model will model some of the things and then do some sort of simulation. So now SOC development is the one. Once this is ready, then SOC development will kickstart. What will do, that's architecture and micro architecture development will happen. The block diagram what you have seen. Then once the block diagram is there, if you look at that block diagram, there will be analog component will be there, digital section will be there. So there will be analog design development will happen. That will get simulated, that will get into the layout, that part will get produced. There is a digital section, there is a group of engineers will be working on the digital design that will produce that design, simulate it and synthesis and taken into the physical design, blah, blah stuff. So the system, this all the digital analog design, there will be simulation, digital design, simulation, and then there or system level we do the simulation and verify this product is functionally working. And then design and test and automatic ATPG. So design and test is the thing. Whenever you produce the unit, you need to ensure and then you are going into the manufacturing. There will be a lot of photo process are involved, and then it's a all very deep submicron technology. What's the guarantee that it's coming out as a right product, or may not be a right product? It's a manufacturing is done correctly, or it is getting damaged during the manufacturing process. So to ensure that there is a design for test and then ATPG, this is my expertise area. And then design for manufacturability, whether it can be manufactured, there are a lot of manufacturing information to be picked up. And then all together we'll do the physical design, then tape out. So SOC is kick off and then do the tape out. Once the tape out is done, next thing is going to wafer fabrication. So now this guy has to get fabricated onto the wafer or a silicon. Then once it is done, then that particular die, it is called as a die, that die has to be tested. Then we need to do, once it is tested, you cut the die and then package it. Then once after the packaging also we need a silicon validation and integration into the system. Then device has to be characterized. The characterized is that, let us say that if automotive industry, people asking, I wanted this unit has to go there and then work for 10 years, which means that as a company, ADI has to guarantee that this will work for 10 years. So that we need to upfront guarantee. So the guarantee, 10 years to be guaranteed, 7 years to be guaranteed, there are specific process involved, testing characterization involved, which means we can clearly classify the life of this product. And then also whenever these products are giving, maybe millions of units we giving, how many units are good, bad, all those things has to be properly done. How much is the maximum frequency it can work, different. And then that way we will ramp up on the production number of unit. We'll create a data sheet preparation, and then is there any tweak is required? Design. Now your mobile wanted to operate on 2 gigahertz. Some of the unit might not be working 2 gigahertz. It may be 1.5 gigahertz. So there will be a different binning process, etc. will happen. So eventually get into the production. Then after that, the yield production is nothing but it's a mass production. Once everything is characterization is done, everything, then we'll just kick off the factory. It will keep getting product. Then yield analysis, whenever things are coming, how much of the yield, whatever you produced, are you getting good amount of yield, etc. Then failure analysis and any return. Let's say if any failure, we need to get analysis. So these are the a lot of different areas are there. Each of this area is having its own wider scope, and then huge number of engineers are dedicatedly working, or maybe one person, let's assume, working on an architecture or microarchitecture. That person in their entire career might be working on that. There may be a person working on digital design, probably that entire career or his career will be working on. This is a huge area in each of the things itself. Now, this is the process involved. Now, let's quickly get into the SOC development flow. The development flow, I mean, this little bit small. Development flow, when we looked at this SOC specification, once the SOC specification, the architecture and design architecture will be coming in. After architecture is finalized, what did happen is there will be two flow. One is that this high level modeling, which is we just model with some C language, etc. And then there will be a sort of checking the things. So the corresponding software also will get developed over here. This is the two flow. So this model software will keep running. Then we'll know, let us say your different application, what you wanted to do, that will get modeled during software and then testing it over here. The same model will extend into the RTL. This is a register transfer logic. This is like either VHDL or Verilog kind of things will get modeled. Then it goes into the functional simulation verification. This RTL will get into the verification stage. So that verification, there is a hardware software consultation. This software will get modeled and then do over here in first C modeling. Then the RTL design, if it is coming, that also software will get validated. How it will get converted into FPG environment. In the FPG environment, the software will get targeted and then validated. This functional simulation will simulate, there will be like VCS, NCSIM, multiple simulators are there, will produce the test bench and then look for the DUT verification. Then the software development will keep on happening. There will be a lot of verification test cases, will get into system level modeling. Then once the RTL is pretty much good, you take into synthesis. So synthesis is nothing but the code is getting converted into the transistor level. And then we'll have a couple of addition on DFT, which is a design for testability. I meant that after manufacturing, how you ensure you are getting one black box of maybe thousands of pin. You don't know whether that is good or not. So we have to have some DFT in it. Once this everything is that you will be having a gate level netlist. So this all flow basically here, this is we call as like a front end flow. From your design getting coded into Verilog or a VHDL. After that, that code will get RTL simulation. RTL, the design is comes over here. Then take into the netlist. After that, this netlist, each gate has to get placed. There will be a place and route. Your memory has to be placed properly. Your physical layer has to be placed properly, and different things has to be placed properly. Then when you place all those things, one flop to another flop, you need to ensure the timing is meeting, different aspects are there. Then there is a little bit physical verification, like you will be having an EMIR, or you will be having an antenna effect, two transistors sitting together, transferring the signal between each other. It might not even do the operation properly. A lot of kind of checks will be happening, which is on the physical, which is called a backend. Once it is everything is ready, design is going to GDS, which is nothing but is a one of the binary format of image which can be taken into the fabrication unit and taken that into the manufacture. So now once you manufacture, you will be getting the post-silicon. The software development also will happen in parallel. You will be having some final code. So you have as the kernels and other software things will be get ready. So now when the silicon comes, you are ready to apply the software drivers and all those things. And then by the time this board also will get, board is nothing but where the silicon is goes and sit with the multiple other silicon in the development board, etc. That's what it is. Then it goes into, once it is validated, it goes into the mass production. Okay, so now a little bit zooming into this area, the DFT RTL design is like a coding. So now this functional verification, I'm just getting a little bit zooming on that area. How that will happen is SOC level or a top level view, you will have it. Then extract all those level features. So we typically spend a lot of time for a SOC level verification plan. What need to be verified? A number of features will be there. So whenever verification plan, if you see that in maybe one SOC, if you take, it may be like hundreds of different document of verification plans are there. Each document may be like hundreds of pages. So that is the way. So each of the feature will be putting together, saying that okay, this has to be the CPU has to function this much of different aspects. Likewise, that plan will be getting reviewed across. Once the plan is get reviewed, we'll take that SOC level Verilog code or this thing, then create a test bench around it, and then start doing the testing. So whenever we do the testing, so some of the all functionality will get tested, and then we'll have a code coverage. So your Verilog code has to be complete. All the lines of the code has to be tested in the process. So now if everything is done, we'll have a change the design and then get all those things comes over here. And then once everything is meeting, there will be sign off criteria. Once it is done, you say that, okay, my verification is done, will go. So this kind of thing, as of now, this verification plan, maybe we are using a tool also to get even this plan to be a verification plan is getting ready. So now I let me get quickly zoom into the backend side of it, the physical design aspect of it. So majorly here, what we do is this design RTL. Now the verified code is ready. Here we log a VHDL. You have a standard cell, IP and technology libraries, etc. Now you have standard cells, other views. This all will take into the floor planning is the first stage. Floor planning is nothing but you have a different memories, different files, and different all those things will put into the silicon different area. You might have a silicon area given 10 mm square, or maybe 6 mm square, or maybe 100 mm square. You will put it that one. Then logical placement, you will have all the gates. Between that, these gates also will be placed in that silicon. Then there is a CTS synthesis, CTS stage is there is a clock tree synthesis. So if the system has to work in 2 gigahertz, you might have seen this whole specification by 2 megahertz, 2 gigahertz and all. If it is working all the flop to flop, the CTS has to be balanced, the clock has to be balanced. These all are, each of the items are like a kind of a half a day topic. So not going too deep into it. Then the routing is all the routing is happened. There will be timing analysis. STA tool will be used, and then PT or a PT from the Synopsys or the Cadence tool, Tempest from the Cadence tool, etc. will be using, and then does the sign off analysis. Then a number of physical verification tools like your Voltas, and then your how the IR drop, multiple stuffs will get verified. All those things are ready. Then it will go into the foundry. So you typically your final backend flow, it typically takes around 16 weeks or 18 weeks of time continuously running. We will have a physical things. There will be two phases. One is a trial run. There will be a trial run, and then there will be a final run like that. So now let's quickly, maybe 10 more minutes. I'll try to close it in 7:15. Then we can open for a question, Q&A and discussion. So now the fabrication. So once this everything is ready, what this GDS, it goes into the fab. It is like kind of image in the binary form, etc. It's sent into the foundry. Foundry, what will happen is that you have a silicon ingot. It's like a cylindrical kind of form. There is a silicon. It will get produced with the that silicon sands and all those things. Finally, that will get sliced. So then the slice will come as a wafer. You will be having a kind of a round wafer, silicon plate kind of things, right? So that will go. That basically a lot of processing steps are there. This is the processing step that GDS will get utilized over here, and then it will do the multiple processing. Typically, again, it will take around 12 to 16 weeks of time. Once you give the thing, everything is automated. It will go step by step. Then eventually you will get a wafer with the die. Each of the SOC will be formed in the square area. So that is our SOC. Then in this wafer, without cutting this wafer, each of the die will get tested, saying that, okay, this die is good or not. This die is nothing but the SOC, and then with a lot of pins around it. Once the things are, once you tested, some of the things may be good, some of the things may not be good, that will get marked. Then rest of the gate, there will be a dicer. It will get sliced and then make it as a die, each of the die. Then that die, the good die only will go over here. The bad die will throw it away. Then good die, if it is taken during the cutting process or any another thing, this may be getting damaged. So some of the things will go away. So from here, the tested die will go into the bonding packaging thing. Then it will get packaged, and then it will go to the, after packaging, there will be another testing. That testing, there may some of the units also will go away after during the packaging process, something might get damaged. Then finally it gets shipped into the customer. So a lot of process on the pre-silicon. This is a post-silicon. And while doing all those things, we need to ensure this guy can work on the this particular temperature, maybe 50 degrees degrees C, also maybe minus 40 C if it is going to be very cold. All those things, we during this testing process, you need to ensure it works. And then packaging. Now the packaging, once this is manufactured, right? This until this, if you get it, then there will be packaging. You have a tested wafer. It will get dyed, sliced, and then there will be packaging comes over here. This die will get bonded. Something you can see that all the pin will get bonded over here. That packaging will get concealed into the thing. That is the packaged black unit is the one which we are getting it. So there is a now, again, another packaging trend is there multiple, this is one SOC, one die, then there is multiple die can go into a single package also. So now that is the kind of a trend, because so many things are going into the single SOC itself, different die goes. This is called a like a multiple, I mean, that is a like multi-die solution basically. So now different packaging aspects are there, depends on the what market it is going, what board it is going to sit, what the power aspect, it will get into the different packaging as packaging. Something is a ball grid array, something is a QFN package, and different package it goes. So now, okay, 10 more minute I can take, I think. So now trends in semiconductor. Just before, now we produce this one. So now, if you really look at number of transistors in each die is keep on increasing. It is going like or double, triple like that. And then your performance is increasing. You need like the mobile has to be working with a very faster thing, faster speed, a very your resolution of the image has to be high, your video performs to be high. So entire things are getting more and more thing, and your typical power watt. The key rule is that make a minimum power. Like if everybody wanted your mobile battery to be extra such a long time. So simple 1 watt, how much of the processing you can do. That is one of the key aspects. So end of the day, your transistors are going, your SOCs are getting complicated. It is going to deep submicron technology and all those things. Now, let's take that is a one SOC. Now, if you take a one IC, one iPhone. In iPhone, let's take a one different SOC. Now, I'm talking about how the things are there. Maybe the Apple is producing a processor, Samsung is producing something else. You will be having a n number of processor from n number of companies goes all into the iPhone. Now, let's say if the iPhone is getting damaged, to whom we should contact? Okay, now once it is there, maybe how do we understand where the problem is? It's all are okay, like $1 million question. So where each of the which IC has to be problem? Is it a board problem? It's a very things will get more and more complex. Now just whatever we talked like marketing, we did a development and test development. So whenever you do the manufacturing in the fab, I mentioned that the wafer test is there. After packaging there is a final test also. So every stage it goes into the testing, finally it gets into the customer. Now customer is utilizing, sometimes it come back from a customer return. See, all those kind of things we need to diagnose is where the problem is there, etc., etc. So all this testing to see make a you have a very big black box to get it tested. So now that how do you efficiently test it? There that it comes a DFT. So whenever we design the chip, we will be having a number of solution M-based, all the memory defect to be tested, M-based solution, logic defect to be tested, logic solution, etc. will get added into the design stage itself. That will have its own verification. Its part which goes into scan chain and different angle. So this that will eventually, whenever your development flow itself, so much of component goes into SOC, that finally will come as a certain pattern. Pattern in the sense that you have a silicon will come as a n number of pins. If this pattern, once the chip is getting manufactured, if this patterns is applied into the SOC, if all patterns are passing, you can say that is a good devices. That's what we do. So here, that is what. So now, before silicon arrives, so this DFT engine will prepare a lot of patterns, lot of timing check, etc., power calculation, blah blah stuff, and then get ready with the n number of patterns that can be directly applied onto the silicon. So now the silicon comes. So another concept is that, let's say you so you are saying that one customer, okay, this unit is going to stay for 7 years. We have to guarantee that. If the unit is not going to stay 7 years, then it is whoever is manufacturing has to pay the lot of penalty. That's the way these things works. And then if the unit is going to the, let's say, aerospace, it might have to work for a very minus temperature. If it is going to the automotive, that you never ever have to have a problem. So if any problem is there, it has to be tested themselves. Whenever you apply the brake, you have to make sure it is getting applied. Whenever the airbag is coming, it has to be ensured that airbag should come if an accident. So when these kind of units are happening, right, this will have a internal self-testing mechanism also. It will keep on periodically test it. In the automotive, the one which goes into the periodically test it, and then if there any problem, it will say, it will give you your dashboard, okay, there is a problem. So before it hits the problem itself, there will be a monitoring mechanism. So many things are there on the testing side. So now after silicon arrives, right, so we ensure that Vmin issue, max issue, yield issue, many things will get tested on the silicon things are there. And yeah, that's what I tried my level best to a very generic and then simplified, not going into a lot into the technical side, but at the same time trying to cover the SOC flow. So being as a analog device or any other such kind of silicon development company, huge amount of work and then innovations and then a lot of people's different thought process, different thing, like 1 to 2 years of continuous development is required to get such kind of IC out. So that's all, guys, I have. Maybe, yeah, you can take it to the Q&A or further discussion.
Thank you, sir. Yes, sir. So basically, sir, this Currently, one second. Yes. So basically, sir, currently even this AI is increasing very much, and this we know this AI workloads also pretty high. Like we know if this chat GPT or something, if it is not working for 24 hour and all, there will be a lot of chaos, and not just chat GPT, whatever the WhatsApp or whatever the platforms, any LLMs or anything. So when this kind of workloads are increasing rapidly, how will be this SOC architectures in general, it is reshaping compared to the traditional old data center designs.
Okay, okay. So whenever this is a good question. The way is that if you look at the SOC sort of block, what's actually happening earlier days, this all AI ML, whenever you look at the AML solution is mainly the MAC. Multiply and accumulate is the major part of the thing. So whenever these chip is targeting to the AML application, will have a these kind of dedicated processor coming into it. So the processing MAC operation may be 1024 MAC operation or 8K MAC operation. So this multiple in a single time, but like real time, we should be able to do that. So what will happen is that that particular IP will get developed, or that more IP or multiple such kind of unit will be added over there. And as and when technology is shrinking, like 5 nanometer to 2 nanometer, 1 nanometer, whatever, that way we can accommodate a lot more transistor into a smaller footprint. So this the dedicated aspect will be coming in. And this is the one side of the design part. You will be having a processor, main processor, you will be having a video coprocessor, you will be having this one, and then you have a these kind of ML related dedicated processors also. So when the load comes, let's say if you are asking from something from the chat GPT in the prompt. So the thing is that it has to the way you are asking, there will be a lot of data to be processed and then or learned, or continuously it is getting learned into the different ML algorithms, right? It will get utilized. So this whole algorithm at the background, it will get kick started. So then it all goes into the different processing. So now let us say your that algorithm, there will be a suitable processor will be there. It eventually land into that processor for the processing purpose. So that is the way it is handled. And then when these processing things are going high, one is the computation. The computation things are moving up. At the same time, you will be having when you are not asking anything in the chat GPT, you don't need to do a power related stuff. So that particular SOC working at the behind, we do cut off the power and then make it. Whenever you are asking something and then this guy is kick starting, you will go and pick up the additional power, higher speed of clock, etc., and then do it. In short, as a long story, if you make it a short, there will be an additional tuned processing mechanism will get introduced as and when more and more demand, things will be more and more will be there. That's the way you can think of the additional loads, and then faster it will be taken it up.
Sir, can you share some real world examples where these kind of mixed signals or even analog components, which is significantly improved this kind of AI system efficiency? Any real world examples from analog devices?
See, maybe let me take one small thing. Okay, so which I'm currently working on. It is a hearing aid solution. Okay, there in that hearing aid solution, I'm not going into the data center and all those things. It's just a hearing aid. So the hearing aid solution, the things it is working. Let's say if you keep that into your ear, assume that you don't have any learning mechanism. So or any then what will happen is that you will be open up for so many interfaces. Let's say your speaker and your mic, it will be always opening up. Now this environment, how this environment, a person wearing the hearing aid, this guy can start walking through a heavy traffic road. Sometimes this guy can sit in the room. Sometimes this guy will be sleeping, and sometimes this guy will be in a classroom. So all the scenarios are totally different. Now you imagine if the system itself learning where this guy is. So now, if this guy is sleeping, understanding that the system is immediately understanding, okay, this person is sleeping. So now what we do, we typically give now the voltage, if you look at, as a each of the IP or each of the transistor is getting, let's say 0.75 voltage. The power is always voltage into current is the power. Now, if the person is sleeping, we don't need to provide that kind of voltage. We can reduce because no processing is happening. So what we'll do is that we will reduce that voltage to a lower level, much lower level. So here some learning happened. So the here learning is happened is that, okay, this guy is sleeping is understood. Based on that, his voltage is got reduced, and then the power is reduced. So that unit will, your recharging will happen very, very less time. Now this person wake up immediately. What is this system understand that this guy is woke up, and then the battery voltage will be, instead of 0.75, it might have reduced to 0.55. That gap itself is a huge saving for a battery perspective. Now 0.55 it get increased to some level. That's a one aspect. So this analog component is there. This analog component is something called a voltage regulator. That voltage regulator has to be adjusted for that. It has to look at now this guy normally it is peaking. It's near a normal voltage. So the normal voltage things will get processed. Now let's say this guy is going into a noisy environment. Whenever the noisy environment this guy is going, in the inside the room, everything is noise reduction processor working. So whenever this guy is into the noise, that environment it will learn, saying that, okay, this person is noisy environment. So if someone else, this all noises has to be cut, then only he can hear it properly. So then that time the noise cancellation unit will pick up. Then it will be little more power. So you can see the same unit, if you continuously using in the public, the battery life will be less, and then if you are using in a room, it will be more. So these all are adaptive learning is happening. This is one typical example. What I am just telling is that it's learning from the environment and reducing the voltage on this different analog component, and then increasing the throughput, increasing the performance, increasing in everything. This may be one of the very small typical example. And also, when somebody talking, let's say in our ear things, I am talking to Amal now, so I can understand your voice. Someone else is talking, someone else is, that tone also has to be understood. So now this all need some certain processing. So now let us say that this processing is already learned and something, then your processing things can be reduced. So many aspects are happening in the behavior. One is the voltage. In this example, the voltage reduction. Another thing is the learning on the thing, and then continuous learning. It may take some more bandwidth like that. Okay.
Yes, sir. Actually, when I was listening to you, one
Mm.
one more question came. One last question.
Mm.
What I thought is like basically this nature. When you said the importance of this conversion and all, overall the nature itself is, I think, very analog. We can say very continuous way things are varying.
Yeah.
Like very most of the natural processes are very
Yes.
it's not like a discrete step by
Correct.
step.
Correct.
So I mean there will be a lot of noise,
Yes.
lot of things. So my question is, this nature basically operating in a very analog way, in a very continuous manner,
Correct.
but most of our computing systems,
Yes.
they are what I felt is fundamentally very digital.
Correct.
So when we forcing this kind of intelligence
Mm.
into a very binary level, like a
Yes.
binary logic level,
Yeah.
um, is this my thought is like are we restricting the ability of the true computing, like are we going to shift to analog systems for better AI efficiency, just like our brain is working in what we said
Mm.
15 watt or 20 watt or something, but our
Mm.
that kind of a billion number of neurons are there. But
Mm. Mm.
to handle a billion parameter LLM model and all, it need massive amount of energy
Mm.
to do
Mm.
the computing. So do we have to go back to this kind of analog? I'm not saying go back or anything, like this digital systems, what is it limiting our ability, or
Okay. Okay.
sir, have you got the question?
Got it. I understood. And then I appreciate this question. Actually, it's a little bit out of the box thinking. And then I think we should think through this way. So currently, first part of this is answer to your question. Currently, it is not. So currently, what all the processing analog world, just on the analog domain, there is not directly on the AI processing, which I was, I mean, from as per my understanding so far, all the analog things will get converted into the digital, and then that digital area, all the analog processing, all the machine learning process happen, and then it will get converted that information back to the continuous form. This is what it is happening. But I like this thought process. The reason is that now today is not there, but tomorrow it can be. So now let's say in analog world, in continuous signal, how can we get a machine learning incorporated there? It's a good thought process. Understanding it's not there, and then all the chip what I worked so far, any like your voice is getting converted into the analog to digital, you will resolution will keep on increasing. So the continuous sampling part, right, in the digital world, if you do, you will ensure that it is not missing the information. So you need a more number of samples not to miss the information. So now if a lot of advanced ADC in the form of ADC that will be there, then that will get processed, then after that it will take a whatever the call. But now in the I'm not sure. I mean, I take that is also a point, and it's a nice thought, basically, by the way.
Thank you, sir. It's a little philosophical kind
Yeah,
of
it's good.
question. I mean, I
Yeah,
used to think about it while I
yeah,
was studying, like whether
yeah,
there will be
yeah,
a very paradigm shift will happen in all our
yeah.
devices and all, whether a mobile and everything will become
Yes,
too much small,
yeah,
or
yeah.
in all, when there will be a very
Correct,
drastic, like photonic
correct,
computing, this
correct.
kind of neuromorphic computing, these kind of areas are emerging. So,
Yeah, yeah.
so I was a little
So
bit
yeah, nothing.
curious
So
about
nothing.
that
Yeah,
angle.
nothing. See, nothing is. There is no impossible thing in this world, right? So today is not there, but tomorrow it can be. It might be a, like there will be a lot change behind that. So earlier days we don't know the like wireless charging. Now we have a wireless charging, and then multiple different aspects are coming up like anything. So it can be. I mean, nothing like. Let's see how the technology evolve.
Thank you, sir.
Okay.
And a few questions are there in the chat. Um,
I am not able
one
to.
question from Ravi Kumar. Rayala.
Is that I am able to see the chat or not? I am not able to see the
So
chat.
I can I will read the question, sir. What is the market scope of digital beam forming?
Mhm. Okay. I am not sure that area. So maybe I'll not be able to answer. I'm sorry about that.
I think it's a digital. And another one question is like, how chiplets are different from SOCs?
Okay, okay, that I can answer. So the chiplet, chiplet is the new things are coming up now. So as we say, now what is actually happening? Why the chiplet? Maybe I'll just give one thought into that direction. So now you have an analog segment, you have a digital segment. In digital segment itself, you have some processing engine, you have some peripheral engine. This processing engine is typically required faster frequency, faster thing, and then your peripheral is needed only the lower thing. So now it can be one way is that it can get manufactured in different technology. That could be so two die you can produce accordingly. So it will be cost efficient. One way, one aspect of chiplet. Why the chiplet? Another aspect is that chips are growing like anything. So there is a limit. When everything is getting manufactured into a single die, you will not be able to get it manufactured properly. So we'll have an appropriate division in the same technology node also that will give you the better yield and all those things, and multiple reasons that the chiplet is comes into picture. So when you say SoC, silicon on chip, and then silicon, the thing is one is you maybe consider that one chiplet is a maybe one SoC. Okay, so this will get designed separately, do everything, and then another guy will get designed separately and all. But there will be an interconnect going through the interposer and all. These two things has to be work together. So this is what it is. So chiplet point of view, you can say that this multiple SoCs are connecting each other. Multiple dies are getting, maybe SoC, I would say the dies are getting connected each other in the same package. Rather than that normal SoC, traditional one, maybe you can say that one SoC die getting packaged for that die alone. Another chiplet point of view, you can say that multiple things are one package. And then this technology also, lot of difference is that something you can say that parallelly keep it together and then connect each other. Something like that, one multiple dies on top of it, and then there will be a via connection between these two get connected. Different packaging things are there now in the latest this bigger SoC like a data center SoC or AML related SoC. Most of the things are need a lot of different computational things, different different level of computing. So that will naturally get into bigger and wider. So kind of SoC will split into multiple uh, and packaged it together. So that's what it is kind of happening. There is a maybe that itself is a one day, 2 day kind of a topic to talk and different thing. I have kept only one slide, the multi-die packaging related stuff in this presentation.
Yes, sir. We got it. Sir, one more question is there. Dr. SP Pradeep Kumar. Sir, can you explain how credit card chips are processing?
Okay. So, okay. So the credit, okay, let's look at maybe let's think about this way. So one of the angle, the processing, what all things need to be processed. You will be having some database at the central area. Now you have a card. So there should be some interfaces which will sense that information. That is one of the aspect. Second thing is that your password or your information should not be leaked out. Okay, so when you put, I mean, I'm just giving a very generic view. So now this credit card systems are there, and then you have in end of the day it is a chip internal to it. So that chip will have some sensing unit. It will go and get sense. It will sort of send some kind of a token. So this token will have some user information and then authentication information. Now you send some token to the destination. That guy will go over there. That guy also, there will be some random some kind of engine. These things will start establishing a communication and then saying that, okay, I have established this communication. So there will be behind, there will be processing. So the information, whatever it is getting passed, it will get processed. Whenever you put the credit card, assume that if you swipe the credit card or a debit card into the ATM machine, so there, once it is get there, it will detect, okay, something is comes up, there is a communication is established. So that means it is already went and sit into the ATM machine. Let's assume that way. So now, second is that whenever you press the button, it will take this button pressing and then convert that into the digital signals there, in that the different kind of buttons are there, and then each of the stage it does. So whenever you type the password, the things is goes through a something called a crypto engine. That is also, there is some module which will get formed into some separate form, and then it will get transferred. So it will be it cannot there is an encryption. That encryption then there is a decryption engine, etc., different form. So that way this traffic will keep moving. So that says that every system you will be having an input unit, will pick up the data, depends on the criticality. It may go into the higher security processing. Some of the thing, if it is not a secure, it doesn't go that way. That is the way it gets processed. There is no single line answer as such because it's very complex internally.
Okay, sir. So, anybody else having any questions? Please text, or you can unmute and you can ask. Sir, meantime, most of us are academics background people here. So, so we will be meeting students in the next tomorrow itself, tomorrow onwards. So, what kind of skill set or what kind of area which students have to be focus more today to what do you say, to stay relevant in the SOC and the semiconductor design sector in the next 5 to 10 years?
See, industry, as of now, we have a higher demand of the resources in all angle. If you look at the person who can currently is who can make a good IP, good core development. That is, there is a demand. Who can do the verification? There is a demand. There is a physical design. In that area also there is a demand. And then there is a huge amount of resources are required to get the shape the SOC. So now, slowly, or maybe currently, we are having a lot of machine learning tools we are using. As I mentioned to you in offline talk. So now, earlier days, the people are coding well. Any of the Verilog code by coding ourselves, saying that all the things manually. That is was the typically interview questions also. When we go to some campus, we typically ask. Now you don't need to do that. You just type into chat GPT saying that I need this particular one. It will give a very nice code without, you don't need to do in the verification also. So these items are emerging. So a lot of area which will get converted, or we are utilizing the power of machine learning. So that power of machine learning, not only coding thing. So now let's say somebody, as I mentioned in the test plan, in test plan, it is an effort. People has to write manually. Now you give a specification saying that this SOC has to work in this fashion. So it give us the verification, I mean, test plan. So then the test code, the AI penetration is getting into very higher scale that. But at the same time, at this point, there is somebody has to validate what AI ML producing it, and then keep going. And then fundamentals of the electronics is still the same, right? So the current SOC VLSI technology, if you ask continue on that, definitely there is a good demand even in this even today. Okay, so every year in ADA also, like we used to recruit maybe hundreds of people from the college, and we'll get into the design, digital design, and VLSI, and then now company is giving a very higher little more package whoever is expert in machine learning and attached to the application. So he is a not only machine learning, rather than if that person is attached to the application or a core field, definitely that will pick up a higher value.
Thank you, sir. That is very insightful for most of us academician, because if we can combine both the machine learning knowledge and our core fundamentals of electronics, VLSI domain and all, there's a definitely there is a huge demand, especially
Which demanded.
ongoing India's semiconductor mission and all.
Yes, yes.
So I
Even
think
now.
anybody any other questions left?
Sir, good evening, sir.
We can take 1 more minutes.
Good evening, sir. Am I audible?
Hi, yeah, you are audible.
Sir, in continuing to the previous question, like if the code is taken from some kind of LLMs, like a fresher who comes out of campus,
Yeah.
how he will be mastering the module integration or debugging kind of thing, like how he will be getting those kind of aspects?
Okay. So if like will happen through the in on project learning. So now let us say the one new guy joined as a, I think will get assigned to a small kind of which he can do, and then there will be continuous discussion and everything. Now let's assume if person is going to write a full adder, I mean very simple form. So when initially earlier we write a full adder in the Verilog code. Now you tell ChatGPT I need a full adder of this kind of things. It will come the code. So now in that simplest form, as a the person comes out of the college can even look at that code. Then we'll say that okay, this comes out nicely. Now, if the scale is going little higher like that, and then now you are going to write some bigger thing, all as of now things are coming as a small segment now. That's what we typically use. And then there is another thing called a chip agent is coming. Chip agent EDA tool itself is a fully machine learning embedded into it. That is companies themselves is qualifying that for their chip development. Now we are next program we are going to start using a chip agent. So it is a continuous process. So whatever it is getting produced, it may be wrong, it may be right, but it is giving a very great coding out of it. Now as a fresher, the answer to your question, some over a period of time he will get expertise into the bigger scale. Until that, multiple stages of things are whether the code comes out is correct or not. Once you just go and look at all your interfaces are there, all things are there. Next level is that it will get validated with the different cases. That way all cycle will be there. It is not that machine learning code you directly take it and then do the physical design and then type out. So huge amount of verification and reviews will happen.
Sir, my last point.
Yeah.
Let us say I have gone through the cycle of SOC design and verification.
Yeah.
And like how I will be getting that board on which it will be validated? Like who has to make that board and who will be providing? Let us say I want to be a part of some, like I'm a part, like I want to have a kind of startup kind of thing or incubation
Yeah.
kind of thing.
Yeah.
Like who will be providing that kind of board, bring up whatever you call it as, how it will be,
Okay.
what is that process, please?
Okay. You mean to say that once SOC comes out, this SOC, you wanted to do the validation, whether this SOC is working fine in the end application. That board you are talking?
Yes, sir. Like let us say I have designed it for some Linux application.
Okay, okay. Yeah. So if you design one SOC, that particular application, whenever the SOCs are going in the company, there will be another team that will kind of dedicatedly design that external board diagram. So the one SOC has to communicate to another component in the board. Let's say it may be power management IC. It may be another flash unit. It may be another thing. That is also altogether a separate design and development in sync with this SOC. Whenever SOC development will happen, we will always give, okay, this particular pin, what is the functionality? Another pin, what is the functionality? What is the clock and all? This information, using this information, there will be a team which will develop the board also, development board. That guy will interconnect multiple SOC into the thing. So it depends on your specific application. There will be a dedicated board development. It won't be a common. There is no common board as such.
Thank you, sir.
Sir, one last question.
Yeah.
Sir, basically, recently I saw one call from in IT Delhi. There is a program called Bharat Bytes. So basically, they're giving students, even young entrepreneurs and all, who have a plan. I mean, who seeking a career in starting a startup in
Okay.
semiconductor domain. So they are giving some funding for through this Bharat Byte one
Okay.
call hosted
Okay.
by IT Delhi. So, sir, what are the startup trend in semiconductor domain in India? What kind of trajectory it is going, possibilities and all?
It's way high actually. So if you really look at the startup aspects, lot of companies are getting formed as of now, especially when the things are coming this AAML. So now this chip agent is the one which I was talking, is a kind of a startup. So what they did is that they have come up with that's what I am saying. Whenever you talk about this machine learning attached with the application, that person can make a wonder. So this is the one startup. So similarly, multiple this is a core product startups are coming. There is an idea, so this has to be automated. That is the idea. They turned that into the startup. Similarly, in each of the design segment, you have this kind of new small like kind of companies are coming up with forming like 4 or 5 people and then getting the fund from there, and then if you have a very good idea, then things will get converted and all. Even analog device, sometimes what happen is that we have a conferences. In that conferences, every year it will happen like either in US, in India, or I mean US one, India. We have some sort of like an incubation idea kind of day. What we do, there is a in-house people, or also sometimes it will be open up to the academia, will come up and then they present it some idea, or we typically give a topic. Okay, this is the topic. People will come up and present some of the good idea, even internally company also funding. So that there will be this kind of scenario also happening inside the company, so that idea can help that idea into the productization. So answer to the short, it's a huge scope, and the solution, if you are successful in the startup, giving a see, everywhere there is a problem. If you are a solution provider, the value is there. It's amazing value.
Thank you, sir. So let's. I think it's time to wind up the session. I think no more questions left. Sir Lashmi, madam, available
Yes, sir.
there?
Yes, it's me, ma'am. Sir,
Okay,
Rishla here. So
please.
thank you. Yes, thank you so much, sir. You had given so much knowledge, information, and we are happy for that. And this is a winding, and I think all the others have clear their doubts regarding this session. And our next section of the second FDP is going to start from 7:30 to 9 p.m. And for that, Dr. P. Revati ma'am, I invite. And the topic is LLM powered research and development for academic. So Dr. P. Revati ma'am is an associate professor in Department of Civil Engineering at
one second, Rishla madam.
Okay. Yes, sir.
So, Radish sir, thank you.
Okay.
And we will be having the discussion later
Yeah,
regarding
sure.
other
Sure.
collaboration possibilities and all. Thank
Yeah.
you, sir.
And yeah, thanks for all, once again, thanks for all this opportunity. And then it was very good interacting with you all. And then yeah, there are some takeaway I have taken from this discussion Q&A, and then it is good for me as well personally. And then thanks for this opportunity. We'll meet sometime soon.
Thank you, sir. Good night, sir.
Thank you. Good night. Bye.
Bye. Rishla madam.
Yes, sir.
Let's invite the next resource
Yes,
person.
so it's the time to invite our next session. That is Dr. P. Revati. She is an associate professor in the Department of Civil Engineering at Puducherry Technological University. She specializes in structural engineering and holds a PhD from a premier Indian institute, including IIT. Her expertise includes structural analysis and technology and civil infrastructure materials. She is actively involved in teaching, research, student mentoring, curriculum development, and scholarly publication, contributing to the technological education and research advancement of PTU. So I humbly request ma'am to start the session, and the topic is LLM powered research and deployment for academia.
I think some technical issues are there. Yeah, we are sorting out.
Good evening, all.
Good evening, ma'am.
Am I audible? Right.
Are you able to share the screen, madam?
Yeah, just I'm trying to do that.
Okay.
Is my slide visible?
Yes. Yes, it is visible.
Is the slide changing?
Yes, it is changing.
Okay. Shall we start now?
Yes, madam.
Okay. So good evening to all of you. And first of all, I would like to introduce myself, Dr. Revati from Puducherry Technological University. And I'm here to give you the lecture on this LMM powered research and deployment for academicians. And this LLM, I'll touch upon the few tools which are available for research purpose. Apart from that, my presentation would go into the basic research methodology that can be done for any researcher, especially a person who is into the academics. So first, let me start with this question. What is a research? So research can be defined as a process in search of a knowledge or any kind of a systematic investigation which will help us to establish the facts about the things which are already existing, or it can also be a solution to the problem which is faced by the people in the industry or in the academia or any common man for that matter. Therefore, so the research has to be a systematic. So we can't do anything which is not getting into the format of a research. So we'll have to conduct a research in a systematic manner, and there should be some kind of a logic that should be adopted while conducting the research. And the research has to be supported with a kind of empirical data, which will be useful for the accountability of the results that is being generated out of a research work. And the research has to be as simple as possible. That's what we mean by the reductive. Something like the solution to the problem has to be the simplest one, because after conducting so many years of a research and giving a solution to a problem, the problem should be as simple as possible so that the solution adopted can be useful, or it can be widely adopted by the people who are benefited out of that. And the research, whatever a person is conducting, that has to be replicable. For example, if I do a research and publish a kind of a results, and if somebody else is trying to repeat the methodology and trying to repeat the steps that whatever I have noted in my thesis, and those results have to be obtained by the other person also. That is what it means that the research has to be replicable. If I do or you do, it has to be reproduced without any constraints there. So with that introduction to the research, let me talk about the types of research that is all undergoing. The types of research, the first and then the foremost one is the pure research or the applied research. The pure research or the applied research, in which you get to collect some information, and that is only for the knowledge purpose. Whereas the applied research will give the solution to the problem that is faced by the day-to-day people. Another type of the research is exploratory research or a formulative research, and descriptive research, diagnostic study or diagnostic research, evaluation studies, action research, experimental research, analytical study or a statistical method of conducting the research, and historical research, surveys, conducting some important surveys, case studies. These are also forming the types of research that can be done by any academician. Now, coming to the pure and then the applied research, it is that study in which the pure research involves only gaining the information, or it is only the in search of a knowledge, like what happened few years ago or few decades ago, few million years ago, what was existing in that place, some kind of a pure knowledge, and that is called as a pure research. Whereas the applied research is the study of finding solution to a problem. So as I told you, to the problems that is existing in the society can be any field, for example. And in case if you are trying to find a solution, and that is a applied research. The why we have to conduct this pure research or the applied research is that a pure research will contribute towards finding new facts, and it will also put an end to the theory that is existing, which may be sometimes false, or it will give us the clarification with the concepts. There is a conceptual clarification that might come in by the outcome of the pure research. And sometimes it is also possible that it would integrate the previously existing theories, and therefore these are the purposes by which or for which a pure research is being conducted. And applied research, as I repeatedly told you, this applied research will give solution to the practical issues or the practical problems, and it will find the critical factors which will solve the problem, or the critical factors which affects the practical problem. And this exploratory research, it is something like you explore or you do some preliminary study of a problem which is not much familiar to you, and in which there is something very little knowledge, or even sometimes there is no basic zero knowledge on that. So it is something like a preliminary work, or you try to explore the field in which not many researchers have not explored it, and that is called as an exploratory research. And the purpose of this exploratory research is that it generates new ideas. So there are many fields which are not identified as a possible research area. So it is trying to identify or explore the the areas which are not explored so far, and it is increasing the familiarity of the researchers with that problem. And sometimes it also helps in the precise formulation of the problem. And this research also helps you to gather the information in clarifying some concepts. And this research will help us in finding whether is it possible, or is it feasible, or is it possible or feasible to attempt that study. So this preliminary kind of a research is called as your exploratory research, where you explore whether is that a potential area to be researched. And this descriptive research, it is like a fact-finding investigation with adequate interpretation data available in hand. And this is the simplest type of a research. It is like you describe your boundaries, and you will have some kind of forehand information which is available to you, and it is designed to gather the descriptive information for formulating more of a sophisticated studies. And the data are collected using the observation, interview, and some kind of a questionnaire or a mail. So using these data, you may try to conduct this descriptive form of a research. The purpose is that you can focus directly on a point of theoretical point, and it can highlight the important methodological aspects of the data collection and the interpretation. And this research may be useful for predicting the areas of social life or outside the boundaries of the research, and it gives you a valuable facts or findings which is required for planning the social action programs. Thus, this form of research is also contributing to the field of the domain of the research by focusing the problems directly. And the next type of a research is your diagnostic study, in which it is like there is some process or some phenomena, and you don't know what is the parameter that is causing this. So therefore, this diagnostic study or this diagnostic research is discovering what's happening, or why is it happening, or what can be done for having that. And this is identifying the causes of a problem and also the possible solutions for it. And this is coming under the diagnostic study. And the purpose of this diagnostic study is concerned with discovering and testing whether these certain variables are they really associated with this problem, or whether these variables are going to contribute towards the solution to the problem. And in order to determine the frequency in which some phenomenon repeatedly occurs, or the factor which is associated with something else or some other phenomena by which it is all getting affected. And next form of a research is your evaluation studies. It is also a type of an applied research, and it is made for assessing the effectiveness of social or economic programs which is implemented for assessing the impact of developmental projects areas. And this results will be useful to design or to accomplish a kind of a value goals and then the objectives. You evaluate. Suppose if this project is faced here, what is the outcome of this development project if that project is based on this area? So that is like you do the evaluation. And this evaluation study will help you to understand the pros and cons of placing that project in a particular area. That's an example that I'm telling, that is called as an evaluation study or an evaluation research. The purpose of this evaluation research is that it will assess or it will appraise the quality and then the quantity of an activity and its outcome or its performance. And it will also specify the important verticals or the important attributes or the important key factors, and then the conducive conditions which are required for the success of the project. It is like before the project is launched, you do the evaluation, and in order for that project to be successful, and you find out the factors which will contribute towards the success of that project, and how to see that those factors are really existing in that field is also a part of this research. The next one is your action research. Here, it is like the researcher will attempt to study the action of a kind of a phenomenon. Example, here it is given as eradication of malaria or a maritime navigation. And this is a process of progressive problem solving, which is led by the individuals working with other in a team, or is a part of a community practice in order to improvise or improve the way they address the issues and solve the problems. So this is a kind of a action research thing. The purpose of this action research is that it is a baseline survey for a pre-action situation. It is serving as a baseline survey for a pre-action situation, and it is also serving as a feasibility study for the proposed action program, and it will help in proper planning and launching of the action research, and it also helps in the concurrent evaluation of the program. Suppose if that action is successful, what is the impact in the surrounding domain or the surrounding field, and that concurrent evaluation is also a part of this action research. And this also helps you to make the necessary changes and the modifications required for the success of this action research or the action program. And therefore, this action research is part of the research in which you completely analyze the eradication or some kind of an useful action, and it will also identify the factors which will contribute towards the success of that action program. Okay, so far we have seen some kind of a research, and the next type of the research is a experimental research. Okay, so this is more commonly used in sciences such as sociology, psychology, physics, chemistry, biology, and medicine, and even some engineering fields. This experimental research is applied. What is this experimental research? This experimental research is a systematic and scientific approach in which the researcher will change or manipulate one or more key variables, and then he will try to control a certain process or certain phenomena, or he will try to measure or quantify the change in the other dependent variable. And this is called as an experimental research. And almost 50 to 60% of the technological research is based on this experimental research. The purpose of this experimental research is to predict the phenomena. We have to, you can have a scale down models or a pilot studies where you can predict the phenomena under the controlled conditions or the controlled environment. And this will help to maintain the control over all the factors. So I told you, in a scale down study or in a pilot study, you will have a control of all the factors. And when you have a control of all the factors contributing to that research, then you have the parametric, the matrices can be changed. Any one of the key parameters can be changed, and then you will be able to visualize or visually see how the output of that phenomena is getting changed, or whether that factor? Is it a significant factor or not? And that can be seen in an experimental form of a research. A blueprint of the procedure that enables a researcher to test his hypothesis. That is what I told. Like it is a pilot study or a scale down model or a blueprint. So this will completely give the researcher the knowledge about applying his solution or applying his hypothesis on a full scale model or on a complete real study. And this is an analytical study. It is related slightly to the basic form of a research in which a system of procedures and techniques for analysis is applied on a data, a sample data. It is not applied on the huge population. It is only applied on the quantitative, a handful of a sample data. And a system of mathematical models or a kind of statistical techniques or numerical tools or any kind of a analytical system will be available in order to see that these procedures are applied to the selected quantity of a data. The purpose of this analytical research is that you can test the hypothesis by specifying or interpreting the relationship with one variable with the other variable. It concentrates on analyzing the data in a depth, and also it examines the relationship between the data in a more relevant, and it will give you the solution as far as possible to the analysis plan, and you don't have to spend much of your effort in conducting the experiment, whereas this analytical research, with the limited tool available, you'll be able to predict the results of your hypothesis if it is applied into the real world problem. The next form of a research is your historical research, in which I think this is self-explanatory, in which you have a systematic collection and evaluation of the data which is related to the past occurrences, and that will help you to know or describe what is the cause, what is the effect, and what were the trends of those events, and which will help you to explain the present events, and it will also help you to predict or anticipate the future events based on these historical data that you collected. And this data is often the archival, which is including the newspaper clippings, photographs, or any kind of culverts or any monuments. And it also includes the data that you receive orally by conducting interviews on noble personalities or even very aged people, or those who had kind of a awareness, or those who were living in those areas, or those who were really connected to that kind of a situation like that. So this historical research is a basic research which will give us enough data about the occurrences which had been taken place in the past, and how does that occurrence has affected the life of people presently, and how it would affect the life of people in future can be found out using this historical research. And there are several purposes of conducting this historical research, but we technological people, academicians, we rarely get into this historical research. But sometimes it is also necessary to know the history of the technology that we are using as of now, how that technology has evolved in different generations or different ages. That should also be a knowledge which will help us in finding the solution to the day-to-day or practical problems. And this historic research will make us to know how the past and then the present are interrelated, and it also gives the reason or gives us an insight what is expected in the future. So if it was the previous era, now this is the era which has been going, and what would be the expectation, or how do we have to address the future generation, and such data or such a detail, such technical intricacies can be known from this historic research. And next form of a research is your survey research. So this is like a applied social research in which you meet different sort of people, population, and you can have a pen and paper, or sometimes you can have audio recordings or things like that, where you have to have an intensive one-to-one or one-on-one in-depth interview, and that research is completely based on the survey, and it is based on the response from the respondents. And this survey research is always conducted in a natural setting, and it also seeks responses directly from the respondents, and it can cover a very large population, and it can involve an extensive study or an intensive study. And this survey covers a definite geographical area, or it can be a city, or it can be a district, it can be a state, it can be a country, or some other any kind of a geographical feature for that matter. The last form of a research is your case study research. It is like you take a case, you try to find the research methodology which is common in social science, and it is based on the in-depth investigation of a single individual, or a single case, or a single group of people, or a single event, and you will explore the causations in order to find the underlying principles. It is something like you take a smaller case or a single case, and that is your case study, and whatever you are able to retrieve out of this research is also a part of the contribution to the research domain. And the purpose of this case study as a research is that it involves an in-depth longitudinal examination of a single instance or a single event in a single group. And it also gives you a systematic way of looking at the events, collecting the data, analyzing the information, and reporting the results. It is applicable, or it is valid only for that particular case. A field research is traditionally been, it is thought that it is something different from the laboratory, or it is something like an academic setting. So here, the advantage of the field research is that it's not that people have to sit inside the lab and conduct the research. It's not like that. The researchers have to face the real world. They have to come out of the comfort zones, or they have to come out of the laboratory or the controlled environment, and then get to know what is the real world conditions, and then we'll have to design the research in the best possible way to discover the particular information required. And that is actually the field research. It is not the research which is conducted inside a laboratory under the controlled environment. Research design. The research design means you have to have a the flow chart or the action items, the drawings for a research. First, where should I start? What is my starting point? What are all the variables involved in that? And how do I proceed with that? So it is something like a flow chart or the drawing for research, and that is called as your research design. And it is the systematic planning of conducting a research, and this will help you to achieve the goals of the research in a systematic way. See, the research design is the arrangement of conditions for collection and analysis of a data in a manner that aims to combine the relevance of the research purpose with economy in procedure, or a master plan specifying the methods and procedures for collecting and analyzing the needed information. So this is the definition for your research design. It is like a flow chart of your research. The need and purpose of the research design is that it will help you in the smooth conduct of the research process. It saves money, it saves manpower, it saves material. It also helps the researchers for advanced planning, and it also avoids the work which might lead to duplication, and it helps you to modify the research in case if you find, because it's not always possible that all the items planned will go as smooth as we expect. There will be always hindrances, there will be always difficulties, and because of this research design in hand, it will help you to modify in case if you find any difficulties while proceeding towards the goal of your research. And it gives reality to the research. So wherever it is possible, you can add or delete the action items and then proceed in achieving the research objectives. In the process of the research, we'll have to select the topic or the problem, and the complete problem cannot be addressed in a single research, and you have to figure out, frame the research design, and you have to frame or simplify the complete problem into your research problem with the scope of it. Since you have a research problem, your research cannot address all the problems in the first attempt itself. Therefore, you can select the problem with some constraints, and that will be the scope. Your research is beyond. You have to define your boundaries, define your scope, so that your research problem is simplified. And then you start with sampling the designs, collection of the data, and analysis, coding, processing, whatsoever is. It depends on the area of the research. And finally, you come out with the outputs, and then you write the reports, your thesis. Okay. This good research design, it should have a proper theory design behind that. It should also be based on the environment that we are working with, and it should have 100% feasibility for implementation in the area that you are working. You cannot choose a problem which is not happening or which is not an issue at all in your geographical area. So there should be 100% feasibility of implementation in your geographical location, and it must have some redundancies. Redundancy means it can have some additional characteristics or additional information or something which cannot be determined. And your research design should be efficient enough in order to give you the output which is useful to the society. Again, this research should be flexible. The research design must be flexible. It should give you an economical solution which should be unbiased, and ultimately, or more importantly, it should fulfill the objectives of your research, and it should be more appropriate to all the aspects of the research. It should give guide to achieve the correct results, and it has to provide a proper scientific base. It should also facilitate to complete the research work within the stipulated time. Your research design should be time bound. You cannot keep on conducting a research for years and years together. You cannot do that. If that solution is going to take you years and years together, then you have to break down. You have to simplify the problem into a time-bound problem so that somebody else in a future scope will be able to attempt to that problem. So this is a functions of the purpose of a research design. It gives you the blueprint of the research. It gives you the limitations or the boundaries or the scope of the research. It will also help us in predicting or anticipating the potential problems. And if at all there is a problem, it will also help you to modify, or it will help you to adjust the parameters related to the research. This component of the research design would be title, the purpose, and more importantly, it is the review of related literature. See, many people, what they do is that they identify a problem and then they go for a literature study. Actually, it should be the vice versa. You fix an area. The title of the investigation can be fixed, and you identify why that study is necessary. The purpose of the study should be clear, and then you collect the related literature in that broad investigation area. After you go through the literature, somewhere you should find that the literature might not have addressed all the aspects of that domain, that investigation. And you should be able to critically review the literature and identify the gap that is existing in the literature, and that is the statement of the problem. But many people do in a other way. They start with the simple problem, and then to that simple problem, they go and collect the literature related to that. It is not so. You define the broad investigation and do the literature. That literature may be directly useful to your research or indirectly useful, but you gain something out of that, and you critically have to review that, and then you come up with a gap, identify the gap, and that gap is the one which is forming the statement of the problem. So when you identify the gap in the literature, this problem cannot be addressed in a single research. Again, you simplify by fixing the scope of the investigation. You cannot address all the gap. Therefore, you have to delimit your problem with the scope, and from that is the first chapters of your thesis, like objective, scope would be defined. Objectives and the variables, hypothesis, like what is the methodology, what is the principle that you are going to apply in order to achieve your objectives. Then the selection of the sample, it depends on the research and depends on the area and the data that is required, or sometimes you may have to rely on the data, or sometimes you may have to generate the data. or sometimes you have to conduct some experiment work, pilot studies, you have to do some blueprint, and then you analyze the data, come up with the solution or come up with a conclusion for that. This is the types of the research design. One is based on the experimental design, other one is based on the non-experimental design. It can be analytical, it can be from the feedback surveys or something like you have a oral kind of a investigation. So here in experimental design, you have a quasi-experimental or experimental. Quasi means like you have 50-50, like a part is experimental, a part is not experimental. And even when you do a part of experimental work, it cannot be the full scale of your research problem. You may have to bring down. Experimental is that completely, your research is a complete experimental. In a non-experimental research design, it can be a case study, it can be an content analysis, it can be ethnography, or you have a focus group, it can be network analysis or a sociometry. Okay, now having identified the literature's gap, everything, you have to come up with a hypothesis. What is this hypothesis? Is that it is a preliminary or a tentative explanation or a principle by which the researcher pretends or claims that the outcome of the investigation will be like this. If I try to do this kind of a principle procedure, it will be the expected outcome. So this hypothesis indicates the expectations of the researcher regarding the certain variables, and it is the most specific way in which an answer to a problem can be stated. So this hypothesis is defined as a tentative statement about a population parameter that might be true or that may be wrong. That is an hypothesis. Now, what's the difference between an hypothesis and a problem? Both hypothesis and a problem contribute to the body of the research knowledge, but hypothesis is different from a problem. A problem is something which is formulated in the form of a question. So this is a basis for your hypothesis to be derived. Whereas hypothesis is a suggestion or a solution to a problem. A problem or a question cannot be directly tested, whereas an hypothesis can be tested and verified. A question is a problem, hypothesis is an answer to that, or it is a solution to a problem. And therefore, you cannot test a problem, but you can test the hypothesis and you can come up whether it can be verified or not. So when an hypothesis is formulated after the problem has been stated, then the literature study has been concluded. When you identify a problem, the problem can be faced in different angles, and the angle or the principle that you are going to adopt is the hypothesis. For that problem, what is the solution that you are proposing? And you will test and you will prove that your proposed solution is the answer to the problem. That is what is called as the formulation of the hypothesis. Once you formulate the hypothesis, the literature study is said to be concluded. Okay, so it is formulated when the researcher is totally aware of the theoretical and empirical background to the problem. Okay, so now we have seen what is the research and types of research and what are all the components of the research. Now, what is this LLM? It is the large language model, and it is a type of an artificial intelligence, AI, trained, which is trained on a massive amount of text to understand, process, and generate human-like languages. And why it is called as a large language model? Because it is trained on a huge database, maybe on trillions of words from the books, websites, articles, and codes. And it contains billions or trillions of parameters, internal variables, which will determine how the process information, and it will make the predictions. It is not based on the keywords. It is actually based on the complete sentence, I can say, for that matter. How would this large language model is working? It is actually working, or it is using a transformer neural network, and this allows them to process the entire sentence at once rather than the word by word searching. Because it is able to process the entire sentence, it will help us in understanding the complex context. And this mechanism will allow the model to pay attention to the most relevant words in the sentence and not by keywords. And this LLM works like a highly advanced autocomplete or statistically predicting the most likely the next word, the token, based on the context of the previous ones. The capabilities of this LLM is that beyond chatting, beyond doing this AI things, it can do translation. It can summarize. This is natural language processing, NLP, which can also do summarize, translate, and it can solve mathematical problems. It can explain the complex logics and by writing or debugging the software code. If I give the code, it gives me the debugged one, and it is also able to draft emails, stories, or even a structured report from the raw data. So that is the basis of a LLM, which is basically the artificial intelligence trained model. And there are some automated AI trained presentation tools, because presentation is most important part of the research, and we should know how to make a appealing or how to present our solution or the problem to the audience. And this is a gamma. It is a, I think many of you may be using it, and if you are not using it, you can try this. It is a tool for converting the text or the prompts into slides. It will give you some modular blocks and then AI generated visuals, and it will give you the slides. And Canva Magic Design, it is again an excellent tool for beginners, where you can, if you give the text, it gives the visual a deck in the form of a PPTX file. And this is another tool, beautiful.ai. And this is using smart slides that will automatically adjust the layout as you add the content. If you keep on adding the content, the layout will be automatically adjusted. And this is ensuring the professional formatting. You don't have to sit and type each and everything. It will automatically adjust the format of your presentation. And there's Microsoft Copilot for PowerPoint. If you have a Office 365 subscription, you can use the Copilot button. And then if you click on that, create a presentation from particular file, or you can upload your research document, and it will create PowerPoint from the document that you are uploading. So this is another LLM trained or AI trained. So this starts the slides from the outline. And you can also prepare a Word document. You can organize your content using headings or using bullets or something like that. Import to PPT. So if you do so, it will generate the AI powered PowerPoint, and you can do that. So there are many AI powered tools which are helping you to generate the PowerPoint presentation. And the first step in the research problem is, as I told you, it is like you have to identify the problem, and I will quickly go to because I've discussed about the identification of the problem, formulation of the problem, then yeah. How do we get the problems sourced? It can be from reading, from your teaching or the academic experience, daily experience. It can be by the exposure to the field situations, or if you are a good consultant, even from consultations or a brainstorming sessions, or from the previous research, or out of your intuition, you can get the problem defined. And how do you define the formulation is that a selected research problem or the idea, it should be scientifically a researched question, and you have to specifically or exactly write what a research problem is. That you cannot give a boundaryless problem, a social problem as your research problem. So there are two ways of stating a problem. Either you make or you post questions, or you make a kind of a declarative statement. So these are all the two ways of writing a problem. And these AI tools, LLM tools, will give you, if you prompt with your keywords, it will give you the way how to frame the problem. Okay. So the process involved in framing a problem is that you have to understand the nature of the problem, and you have to survey the available literature into that problem, and you have to develop the ideas through the discussions, and then you can of course make use of the literature available in the problem. A good research problem should be clear and ambiguous. It can be empirical. It has to be verifiable. It should be interesting. It should be novel. It should be original, and there should be availability of guidance. There should be a proper a mentor or a proper guidance must be available to you. So this is the flowchart or the drawing which gives you analysis of the situation, problem definition, then you go to the statement of the research objective. Okay. Next will be your literature review, and for making the literature review, you have to make a extensive survey of available past studies which is relevant to the field of investigation, and you can have so many online tools for making this literature survey. And the purpose of the literature is that you have to identify the data source, and you have to learn how others have structured their reports, and you have to see that you are not duplicating the problem which is already attempted. Your problem should be something different, something novel, and your problem should not be a duplication of which is already been done in the field. The sources of literature, you can refer to books, journals, e-forms, that is electronic databases, or full. You can have the reports, internet. So research, thesis, dissertations, which has already been done. So here, one important point I want all of you to keep in mind while you do the literature is that you have to record the literatures. Like, what is the the most suitable method of recording the note is that it's a card system where you have a source card and then a note card. A source card is that it is useful for developing the bibliographic information, whereas the note card is the one where you get to know the details available for you to refer. And that is your source card is your reference, note card is your resource. So these source cards will serve two purposes. It will give you the documentary information for the footnotes, and it is useful for compiling the bibliography, and which should be given at the end of the report. At the end of every report, we'll have to see that the complete reference data is available for us. So maybe you can have some kind of a alphabets like B for a book, J for a journal, R for some report, like that R1, R2, R3, or a B1, B2, B3. Because when you start the research, your literature may be new and you will have the complete reference in hand. But by the time you start writing your report, you might lose the phase of the research thing. So that the thread, the link would be lost because you would have been focusing on the experimental or analytical or any other, the hypothesis that you formulated, and the link between your literature may be missing. So in order to avoid that, you must have this complete source in hand. There are many methods of recording the bibliographic information. Like you must have the format for citing a book is that you have the author's name and year, the title of the book, the place of publication, and then the name of the publisher. And for citing a journal, you have author's name, title of the article, then journal in which it is published, the volume, then the issue, and then the page number. Page number should be there. And when you have a single author, maybe you can quote the last name of the single author. Or if you have two authors, the last name of both the authors maybe has to be quoted. When you have more than two authors, the last name of the first author, Atal. And that has to be the quoting style in your research work. Then the note cards will have the detailed information which is extracted from the printed source, and you will have a database of the source card from which these informations have been collected. And there are some automated literature synthesis tools that are available, like semantic search. So this is a tool like SciSpace or Elicite, which will help you to find the relevant papers based on the intent of your research. It is not just based on the keywords of the research. And you have another LLM tool like rapid mapping or citation management. In the sense, when you start developing your report, you can have at the end the bibliography. When you start, you can have a database for that. When you start referring some source card from that, then it will automatically append the reference automatically, and it will relate. Suppose number 1 means if you give number 1 there, it will be able to map the one-to-one relation between the cited article, and it will make sure that the cited article is placed in the at the reference part. Okay, so how to write the review is like there are many ways of writing the review, but one thing is that the review of the literature should not be a copy paste. It has to be something like should be written from the your own words. You have to have from your own words. That's your literature review. And when you have points to be kept in the mind is that you should read the relevant literature, standard literature, and you have to index the literature. The literature should be your original reference. Okay. And to add to that, the presentation findings like auto PPT generation or scientific diagrams, you have the different tools, visual data storytelling. It is also again a AI tool which will suggest a best type of a chart to give the complex data set explained to the reader in a simpler way. The formulation, okay. So after the formulation, you have to identify the variable which will help you to formulate the variable. Here the example is like variable is the sex. It can be a gender, male, female. It can be sometimes 2 or 3. You can also include transgender. And if the variable is like an agreement, it can have 5 attributes or 5 levels. Like you strongly agree, disagree, neutral, strongly disagree, something like that. So depending on the variable, you must have, you should fix the attributes. Then identify the types of the variables, whether it is a dependent or an independent variable. And that in order to identify these types of variables, you should have the pre-hand information of the literature available to you. Only that literature can help you to identify whether the variable is dependent or independent. Okay. So this hypothesis should be tentative and an intelligent guess in order to give solution to the problem. And this hypothesis will delimit the area of the research and keeps the researcher on the right track. It will also give you the scope of the research so that the researcher is not going beyond the scope. Okay. Then the hypothesis should be having a conceptual clarity. It should be specificable. Specificity should be there. Consistency, testability, and expectancy must be there in an hypothesis. Okay. And yeah. So that there are several types of hypothesis, like descriptive hypothesis, where the assumptions will describe the characteristics of a variable. Example, like public enterprises are more amendable for centralized planning. This is something like you describe it. And the next type of hypothesis is relational hypothesis. Example, like families with the higher incomes spend more for recreation. The amount of money spent for recreation depends on the income. So it is like a relation. And next type of hypothesis is that null hypothesis, in which it is stated negatively. That is, there is no difference or there is no relationship. It states that no difference exists between the parameter and the scientific or the statistic being compared to, or no relationship exists between the variables being compared, and such a hypothesis is called as a null hypothesis. Example, there is no relationship between the family's income and the expenditure on recreation. So it is null hypothesis. There is no relationship. Alternate hypothesis, which describes the researcher's prediction that there exists a relationship between two variables, or it is the opposite of the null hypothesis. Like there is a definite relationship between a family's income and expenditure on the recreation. Okay, so this I skip for want of time. Sampling, yeah. So this is another important step in your research. And there are two major types of sampling: probability sampling and non-probability sampling. There are different types of probability and non-probability sampling, like simple random sampling or systematic random sampling, stratified random sampling, cluster sampling, convenience sampling, judgment sampling, quota sampling, or a snowball sampling. So there is some definite rule for these sampling, and one type of sampling is not applicable to all type of a problem. It depends upon the population. It also depends upon the variables. It also depends upon the relationship between the variables. And I don't go with the other. So to conclude with, I go with some of the academic and scientific research tools available. This is Rcet. So this is a language model which will help you to analyze, summarize, and extract the data directly from the scientific papers. The life is very simple. Next is your consensus AI. So this is a search engine which will find answers directly from the scientific research, and it also gives you evidence-based insights. Then Cite.ai, it is a citation tool, reference tool, a citation tool that helps the researchers to see how a paper has been cited, whether it is supported or contrasted or by a later research. That is a Cite.ai. Scholarcy, it is an online summarizer. Because as a researcher, you may find it difficult to read all the in and out of a academic research paper, and then you will find it difficult to find the real crux of that research paper. And this scholarship, this gives you, if you give a report, it breaks into a smaller and digestible summaries. And if you read those, you will be able to get the essence of that complete report. And another tool is your paper guide. So it is a workspace for literature reviews, for data extraction, and citation management. And other one is Zaya. It is also an AI-based tool which will help the researchers to find relevant papers and understand the complex concepts. And the most popular is your ChatGPT. And to deep research mode, it will give you the cited reports, interpretations, Gemini, and then Perplexity, deep research. It is also helpful in conducting multi-step researches. And Claude Search, it is another multi-step research tool. And GPT Researcher, it is an open source that is designed for comprehensive online research. So these are all the deep research tools that will help you to conduct your research with a simpler manner. And Notebook LM Google, it is a thinking partner. It answers your questions, gives the or generates the summary, and it will also highlight the important things in the report, and it will prepare the aids for the study aids. Paperlib, it is again another tool. It is AI-driven summarization of the research. It is also possible. And Explain Paper is another tool. It is specifically for highlighting and simplifying the dense jargon heavy academic text. I don't want heavy thing. I want to have a simplified tool. Then you can make use of this tool, Explain Paper. Long chain or Lambda Index, AutoGen, Gemini 1.5 Pro. So these are all the other extended technical research frameworks. But when you are using these kinds of LLM or AI powered tools, there should be some ethical considerations and challenges. And whatever is the one that you are getting out of this tools, don't try to use it from the without applying your mind. Try to have some application of your mind. Don't take it for granted, and see that you're also applying your intuition into the output of these tools, because it is like these are all some tools, like the sophisticated tools. It is like you ride the train, you travel by the train, but don't jump in front of it. Meaning, if you try to misinterpret the available tool, you will be in trouble. That's what. So with that, I conclude, and I'll be happy to answer the questions from the audience.
Thank you, madam. It was a very important session, especially because of the current relevancy of the research in our academic sector. It is keep on increasing, and most importantly, everybody, even students, also started publishing papers in their even in the second year, third year onwards itself. So we have so this kind of AI tools and all, which can definitely accelerate the research in academic institution, no doubt. Madam, is there any way we can what you say, find out this kind of some gap in the research paper, like by combining a couple of papers?
Yes.
So
Yes, yes.
through ChatGPT we can do it, but is there any fine-tuned model exclusively for combining scholarly articles and analyzing in a
Yeah,
more
that's what I told. No,
technical
scholarship,
way? Apart
scholarship.
from GPT, any fine-tuned model exclusively for scholarly article?
So that's what I told. No, scholarship. It is like it will give you the summaries. So from that
Okay.
you will be able to identify the gap.
Okay.
Paper guide. So these tools will help you to give the summary. So from then you will be able to identify the gap. But whatsoever is that output from those tools, again apply your intuition, apply your thing, and then you proceed with that. Don't 100% believe in the output of these tools, any of these tools. It is all like the tool to make your life easy, but don't become lazy.
That is true, madam, because even these hallucinations are becoming a major issue when we're dealing with this kind of AI tools. It sounds like it's very correct, but it's actually factually wrong. It used to happen so many times.
Yes,
so
that ethics you have to.
Yes. Thank you, madam. Any other questions?
Madam, can you explain the experimental and modeling skill of case studies in the research work? Experimental and modeling skill of case studies.
Experimental, I don't get you, sir.
Modeling skills under the case studies of the research work.
So case studies, it is something which is applicable only to a particular group or a particular field or a particular problem. So when you do that case study, you are going to do some experimental research only to support that case study. That case study itself is not the experimental research. It is like you do some basic investigations, lab investigations, which will add up to the case study. But they are not experimental research, actually. It is like basic experiments.
Okay, madam. I have another one question. What are the common errors in typing and documentations levels? What are the common errors?
Common errors.
Yes.
Yeah. In documentation, no. See, when you do that, the common error is that the researcher will wrongly quote the reference. That one-to-one correspondence may be missing. You would have taken some point, but that will not be properly mapped to the exact literature. That is one thing. Next thing is that the interpretation will be wrong. There will not be enough references to the data given or the pictures given or the table given. So it is like directly giving something like it is observed from this, like that. So these are all the common mistakes. And apart from the grammatical errors, and these are all the technical mistakes which we expect in the report writing. Basically, the reference, citations, bibliographic information, that is the one which is making the major part of the mistakes that is there in the report writing, apart from the typo and then the grammar mistakes.
Okay, madam. Thank you.
There is one more question, like how to reduce AI plagiarism using Chat GPT tools. You have to do original research. You have to have a novelty in your research. And maybe you can do the plag with a reputed or well-identified platforms. And if you want to reduce plag, maybe you can make use of a different keywords, or you see that the novelty of your research is improved. There is no such tool which will reduce the plagiarism.
Yes, ma'am. There is one more question. That is, what are the plagiarism reduce tools?
Yeah, there is no such tool which will reduce the plagiarism. If you get a high percentage of plag, then you have to rewrite the keywords and you have to see that your original contribution is improved. That's the only way. You don't have AI tools for reducing it. Okay.
Okay,
I
ma'am.
was asked to share.
Yes, okay, ma'am. I think all the questions are over. Is there any questions?
No, I was asked to share some MCQ. May I now?
Yes.
Is it required now? So the first question is, research is answer for the first question.
Ma'am, sorry to interrupt. The MCQs are required for the end session for our online examination sessions. So you can please share with the coordinators. Okay, ma'am. Thank you.
Okay. Thank you then. Thank you.
Thank you so much, ma'am, for your valuable information, and
Thank you.
it was a nice talk with you. And I
Okay.
hope.
Thank you. Thank you.
Thank you so much. Good night, everyone.
Nice meeting you all. Good night.
Good night, ma'am. Thank you for your time.